Happy day and welcome everyone. This is just going to be a quick run through of this bonding quiz review. Yes, it's reviewing for the quiz. I'm going to also answer some of the questions along with you just so that you know that you're answering some of them correctly. So let's get started right away. This first part is matching. You can Google any of the answers, but for example, let's do letter B. It says the rule based on the assumption that atoms lose or gain electrons to have a noble gas configuration. Well, what do we call that rule? So if you start scanning through and then all of a sudden you realize, oh, wait a second, I see it. That's called the octet rule. Then you're just going to write octet rule in here, and then you can either put a check mark or maybe like a little slash through it to say that you've already answered that. Let's do a couple more of these. This next one says, I'm going to come down to here where it says, the bond in which 4 electrons are shared by the bonding atoms. Okay, so if I think about this, I'm trying to think, well, I know that a bond is actually 2 dots. So that would be 2 electrons. So what if I had 4 electrons? What do we call that? Well, if I look at my choices up here, I would say, it looks like that's a double bond. So I'm going to come over here and write that that is a double bond. Okay. Let's come down to maybe like the very last one on here. So let's see what the last one says. It says it's a bond in which the electrons are unequally shared. Okay, now, you want to reference your notes. So I'm going to come back to the first page of my notes where I had compounds. Always good to have your notes out when you're doing your worksheets. And what I'm seeing here is I'm seeing ionic, which it tells us about stealing the electrons or electrons are transferred. That's ionic between metal and nonmetal. Covalent is between 2 nonmetals and hydrogen, but that's sharing valence electrons. But I'm not looking for that. I'm looking for sharing, but unequal sharing. And by the way, co simply means sharing, and valent is referring to the valence electron. So let's keep going, because there are 2 types of covalent, either polar or nonpolar. Oh, there it is. Polar says sharing unequally, where nonpolar says sharing equally. So let's come back to our doc here, and let's fill that in. If it's unequal sharing, they said that that's like the polar bears, where the polar bears share because they're both going to get some of the meat, but it's unequal sharing. So that's your polar covalent, okay? And then again, you would just check off that we've used those, and you'll continue doing that. These should be pretty easy. Define valence electrons. Remember, those are the outermost electrons in the outermost shell. You guys remember the duet rule, octet rule. Remember, they want to have how many in their outer level to obey the octet rule? Are you thinking 8? That is the correct number if you're thinking 8. And if you don't remember which elements obey the duet rule, remember its elements numbers 1 to 5. Okay, so keep that in mind for your quiz. All right, next page. So now we've got Roman numeral 6 is what oxygen is. It's got 6 valence electrons, and then we can draw the dot structure. So for example, hydrogen is a Roman numeral I. Remember, you have to look on top of the group. So that means it's 1, and then you just do H with the dots. Okay. Next question is asking to list the 2 major types of bonds. Let's go back to our notes. So if you're not sure, let's click back here and see, okay, well, the 2 major types, they're not talking about polar or nonpolar. They're talking about the 2 major types, ionic and covalent, okay? And then it's going to ask you a little bit about covalent. What is it between? Again, just use your notes, okay? So now let's come down here. Under number 6, you're going to define what an ionic bond is. Again, you can just Google it if you want to, or you can look at your notes. But for this part, I really do want you to really rewrite what A says and what B says on the line provided, okay? All right, now let's come down here. I want to make sure that we remember how it is that we work out our ionics. So we're going to try an ionic. I'm not going to do one of these with you, but I'm going to do one of the ones in the notes with you, okay? Let's try out SrCl2 again, okay? So the first thing that we're going to want to do is we're going to want to take a look at a periodic table to see, is it automatically an ionic? In other words, is it a metal and a nonmetal? Because then you kind of forego a lot of this stuff, and then it becomes a lot easier. So let's check that. Here's our periodic table. I see strontium right here. I see chlorine on the other side. Yes, that means one's a metal and one's a nonmetal. So what do? Well, automatically, no valence electrons. ED, nope, don't do it, okay? I'm actually just going to say X that out. We're not doing it. So what we're going to do is we're going to arrange, and we're going to circle that it's ionic. It's automatically ionic, metal and nonmetal. So now what I'm going to do is I'm going to put the one that I have less of in the middle. So SR goes in the middle, and then the 2 CLs are going to go on either side. No bonds, okay? The bond means they're shared, but ionics don't share, they transfer. So I have to do an arrow showing a stealing or a transfer of the electrons. That's what the arrow is going to show. So now what I'm going to do is I'm going to look back at my periodic table to see how many valence electrons Cl has. Well, Cl's right here, and it says VII, but I have 2 of them, so I have to put those in there. And Sr is here, and it says II, which is 2. Okay, so let's come back here. VII is 7, so I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And Sr is 2. Now, I don't care where you put the 2, but you might want to just put them up here so that you can see. Now, it kind of works like a puzzle in the ionic ones, but chlorine is right under fluorine. And we know that fluorine will steal your electron. Fluorine has the highest electronegativity on the entire chart. So what chlorine is going to be similar to fluorine. Chlorine's in the same family, so they're going to behave similarly. So what's going to happen is this electron is going to get stolen by the chlorine right there, and this electron is going to get stolen by that chlorine right there. And when that happens, because chlorine gained 1, it's now a -1, and so is this one, it gained 1, but strontium lost 2. Remember, losing is positive, so that one's a +2, okay? And so that's how we work out the ionics. Since you know these are all ionic, that's what you're going to do for all of those. So you can rewind and mimic and do what you need to, but that's how you're going to do number 7, okay? All right, periodic table, I've got the Roman numerals up here for your valence electrons. And so let's scroll down here to find a covalent bond. Again, you can Google it. How do you calculate electronegativity difference? So remember, all you have to do is take the 2 and just subtract their numbers. We're going to try one in just a second here, okay? Remember, if you calculate and the difference is greater than 1.8, we said it was ionic. If it's between 0 and 1.8, well, if we look back, we called that polar covalent. And if it's just equal to 0, we called that nonpolar covalent, okay? So let's try one of these out. So we've got S and Br. So let me scroll up here for a second. Here's S, and I see S has a value of 2.6, and Br has a value of 3, okay? So I'm going to come down here, and you don't have to write it in, but this is a 2.6 and a 3.0. Well, what's the difference? It is the absolute value, and the difference between them is a 0.4. So if it's a 0.4, is it ionic, greater than 1.8? No. Is it between 0 and 1.8? Yes, it's not 0. So that means that it must be PC. So use I for ionic, PC for polar covalent, and NC for nonpolar covalent, okay? So that's all you're going to do is just subtract the 2 numbers to figure out what your bond type is. Okay, one more. Now, we're not going to do one of these. We're actually going to do one on the worksheet again, or on the notes. So let's go back and let's try out water, okay? So first thing I'm going to do again is I'm going to look on the periodic table to make sure I don't have a metal and a non-metal. Hydrogen does its own thing, okay? So I'm not going to treat that as a metal. I have to calculate it. So I've got to figure out my H and my O, okay? So it's not automatically ionic, but it might still be. So let's take a look on the chart and see what numbers we get. H is a 2.1 and O is a 3.4, okay? So let's write those down. So we've got our ED, we've got a 2.1, and a 3.4. So I add, so I'm going to do add 1, and I get a 3.1, so it's a 1.3 difference. You can just do it in your calculator. Well, where does 1.3 fall? It's not greater than 1.8, and it's not 0, so that makes it polar covalent, or just covalent. Let's add up our valence electrons. Hydrogen is in group 1, so that has a 1, but I see that there are 2 of them, so I have to multiply by 2. Oxygen says VI, and VI is 6. So now I'm going to add parentheses first. 1 times 2 is 2, plus 6 gives me a total of 8. That's how many dots I need to make sure are going to go around, okay? So which one goes in the middle? The one I have less of, which happens to be oxygen. Put my 2 hydrogens on either side, and then I need my dashes. So remember, ionic, you don't use dashes, but for covalent, I do, because they're sharing. Okay, do we remember? Elements 1 to 5, starting with hydrogen, obey the duet rule. And the duet rule says they only want 2. Well, each bond is 2, so I'm done. The hydrogens are fine. So where are the other 6 dots supposed to go? Now, somebody said, put them in the middle, add another dash. If I add another dash, though, what happens is now hydrogen has 4. I can't do that. So I have to add the electrons in without hydrogen getting messed up. So what are you thinking? are you thinking that I put the dots above the oxygen and below the oxygen? And if you did, that's exactly what we need to do. And now I've got 2, 4, 6, 8. Oxygen's obeying the octet rule. I'm using all 8 of my electrons, and I'm done. Okay? And so that's what you're going to do when you go to do these right here. First, check to make sure. Is it automatically ionic? If it's a metal and a non-metal, it's automatic. You will literally just circle the I, you cross off valence, you cross off the ED, you don't do it. You just go straight to transferring your valence electrons, okay? All right, I hope this was helpful. Good luck with this. And if you have questions, please make sure that you come in, you ask, you text me, do whatever it is that you need. Happy day, everybody.